Good day, grade 11s. Today we are going to look at reduction of angles that are more than 360. Okay, 360 degrees is a revolution, so that means a complete 360 will bring you back to where you started. So if this is my 0 degrees, if I make a revolution, I'm right back where I started. And if you remember, if you remember, we said the graphs are periodic, meaning that the behavior is the same after a certain number of degrees, and for sine and cos is 360. So if you look at this, if we have 770, as you can see, is more than 360 degrees. But that it falls into one of the repetitions. So that means it would have an exact value with an angle that lies between 0 and 360 degrees. So I have a diagram here to explain that. If this is my 0 to 360 degrees, the graph repeats. The graph of sine repeats between 360 and 720, and then it repeats again between 720 and 1080. Now 770 falls into this repetition. Now this point will fall exactly the same as here, and then it will be exactly the same as here. So that means if I were to work with 770, the answer that I would get here would be the same as the answer that I would get here, and would be the same as the answer that I would get there. So that means these the values that are after 360 can be replaced with a value that lies between between 0 and 360 degrees. So how do I find this value that lies in this if I have 720? As you can see, that the 360s that follow after 360 are just repetitions of what is happening between 0 and 360. So that means we can just subtract any unwanted 360s here, from here, until we get a value that lies between 360, between 0 and 360. So we have 770. So I've subtracted the first 360. I got 410. This is still above 360. And then I said 410 minus 360. Then I got 50. Now 50 lies between 0 and 360. So that means sine 770 would give me a value that is exactly the same as sine 50. So that means I have now reduced 770 to what? To 50, an angle that lies now between 0 and 360 degrees. And we are lucky that this 50 is already an acute angle, so there's no need for us to reduce further. Sometimes when you reduce this, it gives you a value that still needs to be reduced according to what we did previously. Okay, now you can see here I've written that this working must be done on the calculator. We don't want to see this working, so you can just take your calculator, punch in 770 minus 360. You check the answer. If it is above 360, you still carry on and subtract another 360. Please be careful when you do that. Okay, so now I have cos 1020. Now I did my subtraction. Cos let's do it together. 10. So you just write the 1020 like that, and then you subtract 360. If you check there, it gives you 660, which is above 360. So you subtract again. When you subtract again, it gives you 300. Now 300 lies between 0 and 360. So this is the first answer that you must write. So you get a mark for this one. Then now if you check here, this 300 is not an acute angle. So it means we must reduce further. So now you do your analysis. 300 lies in the fourth quadrant. So in the fourth quadrant, cos is positive. And then what is 300 going to reduce to? 300 is 360 minus theta, and then you work out what theta is. So theta in this case is what? Is 60 degrees. Okay, so that's how you do it. All right, and then cases like this where now it's the big angle plus beta. So we need to reduce this and write it in terms of beta only. Okay, so you just deal with the value first. So you subtract your 360s that are unwanted here. So 540 minus 360. Fortunately for us, we just need to subtract once. So we get 180. Okay. And then this is still a bracket. So we need to reduce further. Okay. So you do your analysis. The bracket indicates that it is in the third quadrant. 180 plus theta is in the third quadrant. In the third quadrant, sign is negative. So I'm going to write that negative here. And then you replace, and then it's sign, and then you replace the bracket with beta. And then that's all there is to it. So whenever you're dealing with values that are bigger than 360, all you do is just subtract until you get a value that is between 0 and 360. And then if it still needs for you to reduce to an acute angle, then you do as we did previously. Okay, and next we are going to look at reducing angles that involve negative angles. Okay, now you will remember that the direction that we take when we deal with our theta is in anti-clockwise direction, like this. Okay, so when we say theta, we are representing an anti-clockwise direction. Now if I decide to change the direction and go in a clockwise direction like this, so that means I'm now instead of having theta, I'm going to have negative theta. And now negative theta, if I drop that just once, if I go with the opposite direction, if this was 20, if I go negative 20, it means I'm going 20 degrees in the opposite direction. Okay, so that opposite direction places me on the fourth quadrant. Now what happens in the fourth quadrant? In the fourth quadrant, sine is negative, cos is positive, tan is negative. So that means if I have sine negative theta, my answer, if I were to reduce that, it would be negative sine theta, because sine is negative here. Cos negative theta would be positive cos, because cos is positive here. Tan negative theta would be negative tan theta, because tan is negative in the fourth quadrant. So do you see that it looks like for sine and tan, all we do is just factor out the negative. When you factor it out, please be careful that you put it before the trig function, so it goes out and it stays over there. And then for cos, the only thing that you do is just change the sign of what is inside the bracket. So cos negative theta will just become cos positive theta. You just change the sign that is inside the bracket. Okay, so let's look at a few examples. So here this is sine, and as you can see, we've got negative. Okay, so the first thing that we will do, you can first start by rearranging so that it is the number first and then theta. Then because it is sine, we factor out the negative. So factoring out is exactly the same as you did before. So when you factor out the negative, this minus, if you factor out negative, this becomes positive, this becomes positive, and then I rearrange so that it's number first and theta. This is what I did here. Then as you can see, now it looks like 90 plus theta. You reduce. Okay, so we've got this negative that we took out of the bracket. Then we have to reduce further. Okay, sine 90 plus theta is in the second quadrant. So if it is in the second quadrant, it means that we have to now change the sine to cos. So that's what I did here. Now sine is positive in the second quadrant, so that's what I did here. So this negative is this one, and then sine is positive in the second quadrant, so I write that positive, because sometimes it can be negative. And then you reduce this, so sine changes to cos, and then bracket becomes theta. So the final answer, negative times positive, gives you negative, and then the final answer there is what is negative cos theta. Okay, let's look at another example. You have tan theta minus 180. So we rearrange. We always want the number to start and then the theta. Okay, so when I rearrange, I have negative 180 plus theta. Now we don't want negative in front of the 180. So because this is tan, remember we said for sine and tan, we can factor out. So factor out the negative. So when you factor out negative, this one becomes positive, this one becomes negative. Okay, remember, positive divided by negative is negative. So that is why now this has become negative. Okay, again, you still have a bracket, so that means we must reduce. So remember, this one doesn't change to anything because inside the bracket is 180. The sign changes to cos only when you have 90 inside the bracket. Just be careful there. All right, so now we've got negative. So now I have to reduce. So you forget about this negative. Now you deal with the tan on its own. Okay, so tan 180 minus theta is where? Is in the second quadrant. Okay, so now tan in the second quadrant is negative. So you write that first. And then tan comes back as it is. And then the 180 minus theta then becomes theta. So now you've got minus minus. So minus minus makes positive theta. I mean positive tan theta, and then positive tan theta. I wrote this so that you can see why it has now become this. So this is the final answer. You don't need to write this. I mean, I was just showing you why it is like that. Okay, and the last example we have cos theta minus 90. So remember that whenever there's 90, it means that the cos is going to change to sine. Okay, but first we rearrange. So that's what I did. Minus 90 plus. Remember, when you rearrange, the number takes the sign that is in front of it. So negative 90 now comes to the front, and then this is positive. So it will be positive theta. Okay, so now this 90 luckily doesn't need to, like, we don't need to take, it's between 0 and 360. So we don't need to reduce that number. So the only thing that we need to do is, okay, because this is cos, we don't need to factor out the negative. So the only thing that you do is to change the signs inside the bracket. So because we said cos negative theta is the same as cos theta, so we change the sign of what was inside the bracket. Okay, so negative 90 becomes positive and positive theta becomes negative. So please don't forget that. For cos, you don't factor anything out, you just change the signs inside the bracket. Okay, so yeah, then when it is like this, now 90 minus theta is in the first quadrant. So in the first quadrant, cos is positive, so that's why there's nothing here. And then cos then changes to sine, and then bracket becomes theta. I hope that is clear. Please do exercise 4, number 1, as it is indicated number 2. I've given a hint here: reduce each function and then simplify. And then number 3, you do all of those. Thank you.